Welcome to Groundwork, a podcast from McClanahan Corporation to talk about key material processing topics. From agriculture to mining to material recycling, we discuss the best ways to process the raw materials that powers the world. Because if it's not grown, it's mined. I'm Alan Bennetts, the Global Group Product Manager, and I deal with wet processing for McClanahan, a lot of different things, but part of my area also includes pump, which is what we're going to be talking about today. And I'm being joined here by Tony.
Yes, I'm Tony Bryant, North American Sales Manager. Been with McClanahan about 18 years. Got some field service, commissioning plants, about 8 or 9 years out there, and been managing parts and service since.
I've been out in the field working in operations for quite a few years. Then I came over to this side where I started working on the manufacturer side. And I can tell you one thing, it's always important to have people who know the products that we're dealing with. So it's great that you've been involved in the field service and on the parts side of things, because it really helps the end user in the end. As I said, we're going to be talking about pumps today. And I guess for one thing, not everybody is as familiar with pumps as you and I. So you want to give a brief explanation on what a pump is, Tony?
Yeah, a pump is basically moving a slurry like a conveyor. It's moving material from one part of the plant to the other.
And that plays a real big role in part of the process, because you have other pieces of machinery that depend upon the pump delivering that material. So it's taken, to get in the more technical side of things, it's transferring energy into the slurry through centrifugal force and creates a pressure differential within the pump, and it puts it through the lines or piping that we're going through. So that's why it's really important as part of the system, because it doesn't necessarily provide a lot of performance enhancing to the system, but it makes the rest of the system work. That's why it's so important that a good pumping application is sized up and dealing with all the scenarios that would come down the pike, making sure it deals with the dynamic head, the pressures, just getting it up to a cyclone or anything else that the pump is delivering to. Like you said, it's a conveyor, but it's dealing with slurry through the system. Conveyors don't necessarily harm the system, but a poor performing pump really can harm the system. So, since it's a centrifugal pump, we have to break it down into, the aspects of it, the components of a pump. It has the casings, it seals it up inside, but then the main workhorse of the pump is the impeller. And as the slurry comes into the impeller, it's spinning around, and the best explanation I've ever heard about it is centrifugal force is kind of like when you're on a merry-go-round, and that's what's going to spin you off of the merry-go-round. Well, that's what's happening here. As the slurry comes in, it gets spun away from the impeller, creates a pressure differential going into the casing itself, and the casing has to be strong enough to handle the pressure. So if you overpressurize the pump, then your casings can start to fail. But it has a discharge point, and it allows that pressurized slurry to discharge out that outlet and then convey itself down the rest of the system. And that's really the nuts and bolts of it. The technical side kind of gets into the way sometimes thinking about it. I mean, how many times have you run into someone who overthinks a pump, Tony?
Oh, yeah, that's quite often, for sure.
Tony, as part of your job, you have to deal with people calling in all the time, requiring maintenance and things to go through. What are some of the biggest things you have seen about maintenance and making sure that they stay on top of the subject?
Yeah, one of the biggest things is just the gland adjustment, being able to maintain that 5 to 55 drips a minute. That's important on the D gland or the dry gland, and that in itself will cause a number of different failures. It could be issues with your bearing assembly, where if you've got big gush of slurry just going at the front cover of the bearing assembly for a while, it could get slurry inside the bearing assembly and fail the bearings, or it could cut the sleeve in two. And if it continued running, it could cut the shaft in two on the bearing assembly.
Yeah, it's definitely an issue, and that's actually possible for the hydrostatic gland also. For those of you who are not familiar with the D gland or the drip gland from McClanahan, it's a mechanical gland that we have that allows you to run the pump without any um, add water or clean water, gland water, to be brought into it. It uses the slurry itself to help keep things cool down there in the face shield and everything like that. So it's a very straightforward, simple mechanical gland that allows you to operate a pump out in the field without any additional clean water to go through it. Um, it's very similar in the type of process of the hydrostatic gland. With if you don't have the water going in there properly, the same thing can happen with a hydrostatic gland. The slurry starts coming out the back and starts blasting on that bearing also. So you have to keep both of those adjusted properly to keep those bearings from getting washed out or getting a lot of grit inside of them. A lot of people like the hydrostatic gland because it's a little more fire and forget. With the D gland, you do have to adjust it. So, I just recently had a customer who was talking about the glands, and I don't like that, because they have labor shortage. And from your experience, which takes a little bit more labor, the D gland or the hydrostatic gland?
The labor side of it, it could be, it's the same. I mean, there's not going to be any difference because it's adjusting three nuts. It doesn't take but just a short time to do this. So, yeah.
It's just really more of a mindset. With a hydrostatic gland, you're not looking for the drips or anything like that. It has a steady drip. For some people who don't pay a lot of attention to their pump, the hydrostatic gland may be a little bit more usable for them, while the drip gland the biggest advantage the drip gland has is it goes out in the middle of nowhere with no water, meaning no gland water or anything like that. That's the biggest benefit of there. So you don't have to have clean water to go to it. But the gland plays a major part in the pump performance, because if the gland fails, what are some of the negatives that when the gland fails there, Tony?
So when the gland fails and you continue to run, what you're going to get is a large amount of slurry uh, pushing toward the front cover of the bearing assembly. And as you continue to run, that's going to cause failures in bearings. It's also going to wear away at your gland sleeve. And if you run it long enough, you can potentially cut your shaft in two on your bearing assembly. So, and all these things have happened.
So it's not just the maintenance of the pump. You have to maintain like the sump area ahead of it. Make sure that foreign objects don't get in there.
All kinds of things can go through that pump.
So and you divide the maintenance of the pump up into the wet end, which deals with the gland and everything going in it, the impeller. You have to tear apart the pump every once in a while to see the inside of it. But on the other end of it, you mentioned the bearings and making sure the bearings don't get slurry into it. That's part of the gland's purpose. But how many times have you seen slurry coming from above dropping down onto a pump?
Oh, that's quite often, and that's a problem with the motor itself. That can affect the motor, the pump itself in the gland area, and the bearing assembly itself.
Yeah, so I guess when it comes to maintenance, you just can't focus on the pump. You have to focus on the environment around it. The sump, making sure slurry doesn't get onto it. The bearings themselves can fail really quick. There's a lot of stuff put in place for it to protect those bearings, but constant slurry hitting into those areas, you can overheat motors. You can just get grit into the bearings themselves, and they tear up real quick because they're moving at high speed. So not like it's going to sit there and slowly grind on there. It's going to fade real quick.
Yeah, it could be as simple as somebody trying to do a good job, go out, clean the pump area up around it, the pedestal with a hose, and then take the hose and aim it toward the bearing assembly front cover or rear cover and drive the force of that water inside that bearing assembly and kill it.
Yeah, so maintenance is not just necessarily taking care of the equipment, it's taking care of the environment around it. So, hey, just out of curiosity, what's one of the worst, when you did field service, what was one of the worst damages that you ever seen happen to a pump?
There was a hydrosizer in Wisconsin. They were running this hydrosizer just with the operator, the loader operator. So he was just watching the plant run. The hydrosizer filled completely up with sand because the valve quit working. It filled all the way to the very top of the cyclone, and then it backed all the way down to the pump. And as the pump kept trying to pump slurry up, it eventually got to where it was just a solid line of material. And the pump totally melted down. All the liners, all the impeller, and sand was like piled up over the bearing assembly on both sides. So,
I didn't actually, the worst one I ever saw or heard about, I didn't actually have it. It was one of our applications individuals. He was on site and, like you said, the line got plugged. And the pump is going to keep trying to put energy into the slurry and it's going to get hot. And eventually, water is going to turn to steam. And eventually, that's going to cause additional pressure on the unit. And they ran this for so long, it eventually caused all of the rubber lining to melt, which that's going to happen earlier on. But the pressure and the heat got enough that it overcame the strength of the casing. And there was a complete failure as the pressure blew the pump apart. Monitoring line pressure, line velocity, just making sure your pump is still pumping is a very important part. Getting plugged is not just having to go through and clean out lines. You may do some damage to that pump. And if it has been plugged for any amount of time, turn everything off, let it sit for a period of time. Don't go in there because it's probably going to be pretty hot. Even if it doesn't feel hot to the touch, the inside can be pretty hot. So there's a lot of safety precautions. If you plug a line, my best recommendation is to leave that pump sit for, 30 minutes to an hour before you tear it apart. Moving more into less of catastrophe type situations, but, what are some of the things we should be looking at for maintenance for daily, weekly, and monthly inspections?
sure. For the daily maintenance, the key is just when you're walking by the pump, check the drip, make sure it's still 5 to 55 drips a minute. Listen for any kind of unusual sounds, bearings, um, any excessive heat. Make sure that if the vents on the motor are covered up with sand, or as you mentioned earlier, if there's a leak coming down, and it's just causing this massive amount of sand dumping on top of the pump to get that sorted out. And on a weekly basis, you're going to want to grease the larger pumps on a weekly basis, and the smaller pumps on a monthly basis. And other than that, I mean, it's when you get out to 6 months, you're going to want to split your casings and you're going to want to inspect internals. You're going to inspect the impeller, the liners. And what you're looking for when you inspect these is you're looking for metal showing. That's what you're looking for. If you see metal chunks going out of the impeller, it's time to replace it. Uh, when you get ready to go back with the suction line, you want to make sure that the flange of the suction bush liner doesn't fold over. These things are pliable when you replace them, and you want to make sure that the flange has a good seat when you go back with your hose. So
And that, we're mainly talking about rubber line pumps. And by far, that's the most common type of pump within our industry, just because the rubber has a tendency to be much more cost effective for the wear aspect of it. Um, but, the industry is changing a little bit here and there, and we are running into sand particles that are manufactured sand, having gone through a crusher to get it down to a specific size. And this sand tends to be real sharp or jagged. And when it comes to rubber line pumps, what have you seen happen to that when you're dealing with manufactured sand?
oh, it will shred the liners just in a short while. I mean, if it's man sand, it can within 2 or 3 weeks take your liners out, and so yeah, we've got options for that when that happens.
Yeah, and the first line of defense would be to really go to a metal impeller. And that's kind of dealing with like sharp sand, where it's not really attacking the liners themselves, but it is attacking the impellers, because that's where the wear is going to happen first, is at the impeller. And then the next step would be to go to a full metal, hard metal pump. When it comes to maintenance on that side of it, you also need to think about the material going in there. And, if it's wearing away too quickly, maybe you're not necessarily wanting to go with the rubber lines, even though rubber liners tend to be the most cost effective. There are certain situations where you want to look at something different. And, you know, as a pump manufacturer, we have those options for alternatives. So looking at signs of wear and failure before you even open it up, you can kind of tell where there's going to be, excessive wear on a pump. Can't you, Tony?
Oh, absolutely, and if you're seeing pressure drop on your cyclone separator, that's a big telltale sign in itself. But yeah, you're going to be able to tell.
Yeah, the line pressure is one way. If you're not getting that flow rate, it's always recommended to have like a pressure gauge at the discharge of your pump. And, if that pressure is going down, or if you have a flow meter on there, monitoring that is definitely a great way of staying ahead of wear problems within it. Failures, on the other hand, um, you know, barring a catastrophic failure with no wear into it, um, those tend to be pretty rare. So the wear indications will give you a heads up long before it has that catastrophic failure.
Yes, yes, for sure.
Um, going into it, having been in the field service and now dealing with being the aftermarket sales manager, what are some of the tips and tricks that you would have for people performing maintenance?
If we're going inside the pump and we're actually changing out the liners, I guess that's something that a lot of people struggle with, is getting the flange inside the suction casing, and it's a matter of taking a 18 gauge cable and wrapping around it and putting a little Dawn soap suds on it, and you can get the liner to pop right in. So it's that's one of the things that I can think of right off. So
Well, I hate to admit this, when in my operation days, I've been involved in a couple of situations where people would bump the pump. Um, they might wire it up backwards and bump the pump trying to get the impeller off. Have you ever seen that type of thing? And what do you think about that?
uh, I think that's doesn't make a lot of sense to do that for sure. I have seen quite often where they are actually wiring the pump in. This is on new operations most times, where they've changed out something. It could be a soft start. It could be whatever, and they actually run the pump backwards. And normally, when you run that pump backwards within just a matter of seconds, you've ran that impeller all the way into the such and side liner. So yeah, I would not recommend that for anybody to bump the pump.
Yeah, I'm pretty sure MShaw has put a kibosh on that in the first place. But um,
And also, I mean, just checking your belts on your pump. We normally, as a quick method, we're going to go out and do like the half twist method. You're basically grabbing the belt in the and making sure you've got it locked out, of course, but make sure that you go to the center of the between the two shivs, and you're just trying to twist that belt halfway. And if you can go more, it's too loose. If you can't go enough, it's too tight. That's just a simple method to be able to check the belt tension.
yeah, that's something you can do without. I know there's some fancy tools out there that'll do it, but a good experienced hand has that ability to go out and have a feel for a pump, and that's kind of an important thing when it comes to maintenance. Um, Reading it out of a manual and going out there a first time, a good mechanic will eventually pick it up, but someone who has experience around pumps is going to see things that even a good mechanic who doesn't have that experience is going to not be able to see. Just grabbing the belts like that, obviously in a safe manner to get a feel if they're tight enough. Those are some of the leg up that you know experienced pump mechanics will have over someone just getting into it, and that takes a lot of time. And unfortunately, we're not seeing as much of that experience out there in the field.
Yeah.
Have you been seeing a decline in you know pump knowledge when it comes to maintenance?
Yes. Yes. We're seeing it across the board. It's just where the older hands are retiring out, and they're bringing new people in that have no experience whatsoever, and it takes time. To, it it gets to the point to where when you walk by that pump, um, you can listen. You can walk by and listen. You can tell if the pump's pumping right or not.
As you're listening to the pump, there's a lot of different things to listen for. Could be just the motor itself, but listening to the pump itself can tell a lot of different things. One of the things that gets talked about with pumps a lot is called cavitation. A lot of people talk about cavitation, and there's some misconceptions about cavitation in itself. They sound similar to what's happening. Is sometimes you'll get air inside of the pump itself, and that will cause some damages within there. But that's not actually the true cavitation. Um, it'll damage the rubber liners. It'll damage the impeller. So it's never good to get air in there. But what happens when it comes cavitation is there's micro bursts of phase changes of the slurry itself, and it acts like little explosions on the surface of either the impeller or the liners themselves. And like I said, it's acts like a minor explosion within there, and it causes pitting within the system itself. It'll tear apart rubber, and it'll also cause pitting within metal pumps. And there's a lot of different aspects to that, but you can hear that as you're walking around. You've heard it before, haven't you, Tony?
I have, Alan. But one of the most common things that I see out in the field is actually um, the sump level becoming too low, and we wind up with a vortex basically, and this vortex and sucking air, and that's a pretty common happenings out in the field. So
Yeah, getting air into a slurry system, that is never a good thing because um, you're putting a lot of energy into it. And energy also implies heat, and things will heat up, and air and water do not expand at the same rate when they get heat. So that's where a lot of the problems come in. So um, you can hear it like within the pump, it sounds like marbles going through there. And that's probably the biggest thing. And getting air in there and actual cavitation, they sound very similar, but they do have different problems within them.
I just had a startup a couple of weeks ago. A customer called in, and he was having he was actually having issues. He thought he was having issues with the pump. He said it just didn't sound right. And I said, well, what did it sound like? He said, it sounds sort of like popcorn, something crackling inside the pump. And I said, that's air. It's a new system. There's air all trapped in the lines, and you're going to get that in the beginning. So
listening to the pump is by far, the preventative maintenance going through there. And that's, kind of going what we've been talking about with the experience going behind it. Walking by a pump that's making a weird noise, that should be your first red flag that you need to take a look inside of it. Because you're not going to diagnose what the real problem is until you take a look inside. Multiple times I know you've had some guy called me up and said, the pump just doesn't sound right. He doesn't know exactly what the problem is, but it just doesn't sound right.
Yep. That happens quite often.
And, that's why they rely on you, is because you can, walk them through some of the most scenarios that are causing those type of problems. So I guess jump to winterizing your pump. What would you say the biggest thing that you need to do to winterize your pump?
You want to make sure that you've got your system drained of all slurry water, and you're going to make sure that you pull that drain plug on that pump. And from that point, you're going to want to take that plug and put it on your stud and put a nut on it where you can find a plug when you get ready to start back up.
And what if we don't, not everybody has those plugs. So if we don't have a plug, what do you have to do to the pump if you don't have a drain plug on it?
You would actually have to break the casing open to be able to drain it.
Yeah, just enough for everything to get out and drain out.
Yes.
And I know a lot of people don't like doing that because it's some effort to it. I've had multiple people come up to me and, hey, can we put antifreeze in there? Have you ever had that come by you?
I have. And that's a no.
Why would you say it's a no? I know I have my answer, but let me hear yours first.
So, yeah, you don't want to put anything on rubber that's going to actually, any kind of petroleum products or anything that's going to affect the rubber.
Yeah, and because hydrocarbons or any type of alcohol will attack that rubber and degrade it and decrease its overall wear life, if it doesn't ruin it right then and there.
And increase the size of it.
Yeah. A little secret. I love this thing. It happened back in World War II. The bombers used to go into, and drop in their bombs, and they'd get shot up quite a bit, and they'd have bullets go through the fuel tanks. And what they eventually learned to do is wrap the fuel tanks in rubber, because as soon as the fuel got on the rubber, it swelled up and sealed the fuel tanks so they didn't leak fuel as much. So that's what you're talking about. If you can stop the leak from a bullet going through your gas tank with the swelling of the rubber, what do you think it's going to do to your pump in the first place?
It's going to seize it up.
Yeah. It's just a precaution that I'm not sure I would want to take, because anytime you have that liquid in there and it freezes or expands, it's going to cause some of that damage.
And then I get that call that, hey, I've went out and my casings are cracked. My casings are broke. Do you have casings in stock? So, yes, the best thing to do is drain all the liquid out of them, and you're good to go.
Yeah. So I know not everybody likes hearing that, but getting that water out of there is by far the best thing you can do to winterize your pump. And then also making sure if they are rubber line pumps, make sure that if you do have them opened up completely, don't leave the rubber out in the sunlight. Because if you are breaking it off for maintenance and you leave one of the casings off, then you leave it half open, thinking, well, now I won't have any water in there, but now you have sunlight beating down on that rubber, and that's not a good thing either. So leave it in place, slightly cracked if you don't have a plug. Better if you have a plug. As we close up this, Tony, what words of advice would you have for someone who has a pump out there and wants to keep it as running as long as possible?
maintain that gland. That's the key to one of these pumps having a long life is maintaining your gland. I'm talking big gland, packed gland, hydrostatic. It doesn't matter. You still need to maintain that gland because if you're spraying slurry, water towards your bearing assembly, you're going to eventually have all kinds of issues with bearings. You're going to have issues with sleeves, and you're going to have issues with your bearing assemblies. So maintaining that gland.
Good to know. Pumps, they don't seem glamorous. They don't seem necessarily all that fun. When you have to break them apart, you're usually not in a good mood. But when they work, they make your life so much easier, and they make the rest of the process work properly. And then that's when you can start making money with your product. Thank you for listening to Groundwork, a McClanahan podcast. Be sure to subscribe on your favorite listening app for new episodes and follow McClanahan on social media for new content.